The second part of our video demonstration focuses on manual blending with the product mixer in Petroleum Refining Library. In real refinery operations, mathematical calculations alone are not always sufficient to determine the optimal blending recipe. Blending behavior can involve complex effects, while production recipes are often based on historical operating experience and previously successful blends. The manual blending algorithm is designed for this type of scenario. It allows the operator to define their own linear constraints and objective function, which the product mixer then uses to calculate a feasible blending solution. Instead of optimizing only product properties such as octane number, vapor pressure, or sulfur content, the model can incorporate historical blending data, such as the proportions of individual streams used successfully in previous production runs. As you can see, the product mixer receives 4 streams. Fractions with initial boiling points of 85 degrees Celsius, 50 to 100 degrees Celsius, and 85 to 180 degrees Celsius, plus a pentane-hexane fraction. The statistics of previous successful blends are shown on the right. Based on this data, blending constraints are defined for the production of light degassed gas condensate, LDGC. For example, the combined share of the 50 to 100 degrees Celsius and 85 to 180 degrees Celsius fractions must not exceed 60%, while the share of the 85 degrees Celsius initial boiling point fraction must be at least 25%. These conditions are converted into a system of linear constraints, which the product mixer automatically evaluates as the incoming flow rates change. If the 85 degrees Celsius fraction is completely stopped, LDGC production also stops because the minimum share requirement is no longer satisfied. When the flow of this fraction is increased, production resumes. The operator can also modify the objective function, production limits, and component share constraints. For example, after removing the minimum share requirement for the 85 degrees Celsius fraction, LDGC can still be produced even when this component is no longer supplied. This example demonstrates how historical data from successful blending operations can be transformed into mathematical constraints and used for dynamic control of finished product production. You can watch the full demonstration of the model in operation on our website.